Okay, hi guys. This is another volumes by cross-section video. We have a new problem that we're going to work on. So you might pause the video and write this one down. We are going to find the volume of a solid with a base bounded by x squared plus y squared equals 9, where the cross-sections are equilateral triangles parallel to the y-axis. It's like a small paragraph here. So basically, here's how you get started. This is our graph that we're bounding it by. So let's start by drawing a sketch of what that looks like. And I'm going to scoot this up. Hopefully you've kind of written it down. We're going to start by drawing what is x squared plus y squared equals 9. So x squared plus y squared equals 9 is the equation of a circle. 9, if you square root it, is plus or minus 3. So it's a circle that goes over 3 and back to negative 3. Up to 3, down to negative 3. It's a graph bounded by this. So we're going to get this nice circle, hopefully, that I can make not look too weird here. Okay, there's my circle. And we are going to stack equilateral triangles parallel to the y-axis. So my slice, my object that I'm stacking, is an equilateral triangle, a triangle with 3 equal sides. And I happen to know that if this is let's call our side of our triangle S, then this is S and this is S. All 3 sides are equal. I'm going to need the area formula for this triangle. So area of a triangle is 1/2 base times height. But for equilateral triangles, there's a shortcut formula. You can use radical 3 divided by 4 times side squared. It's the same as doing 1/2 base times height. It's just kind of an easier formula when it comes to finding the area. So I'm going to use that. I'm going to have to come up with an equation for my S, for my side. So I'm going to go over to my picture here. One side, let's say this is our side of our triangle that we're studying, is supposed to be stacked parallel to the y-axis, so going this direction with the y-axis. So this red line that I just drew in the circle, that's side S. And I'm supposed to write an equation to represent how long it is, because side S is going to change. If I drew it over here, it's really short. If I drew it over here, it's pretty short. If I draw it in the middle, it gets longer. There's going to be infinitely many triangles stacked in here, lots and lots of sides. So I want an equation. So you know how we have this equation for the circle, x squared plus y squared equals 9? I'm going to solve for y. Y squared equals 9 minus x squared. I'll take the square root of both sides, and I'll say y equals plus or minus square root 9 minus x squared. And the reason I'm doing that is because the plus or minus gives me the equation for the top and bottom of this circle. This top piece is y equals plus the square root of 9 minus x squared. And then the bottom of the circle is y equals negative square root 9 minus x squared. And that's helpful to me because this side is bounded between those graphs. In fact, if I was to ignore the bottom half of this circle, the top half of the circle, this length, is determined by this curve. So it's really 2 of these. If I took this and this, these 2 lengths, and put them together, that's my side. I could say S equals 2 times radical 9 minus x squared. Basically. 2 of these gives me the top half and the bottom half and gives me the full length. So my area formula that I wrote over here, A of x, is radical 3 over 4 times side squared, but I just figured out my side is 2 times the square root of 9 minus x squared. So we're going to square that. That's my side squared. And then whatever this cleans up to be is going to go in my volume integral. So I'll move this up. So now I'm going to say, okay, area equals, I'm going to clean this up to radical 3 over 4. 2 squared is 4. And a radical squared cancels. Radical squared cancels to just 9 minus x squared. And so I can see that, oh yeah, these 4's are going to cancel. And I'm going to have radical 3 times 9 minus x squared. So volume equals integral radical 3 times 9 minus x squared dx. The bounds for my integral come from the x-axis. This is an x integral. Everything's in terms of x's, so the x-axis helps us do the bounds. It goes from -3 to +3 on the x-axis here. So I'm going to write -3 to +3 on my integral. And then we're ready to solve. So let's plot the radical 3. Volume equals radical 3, bounded from -3 to 3, of 9 minus x squared dx. And then to reverse this is going to be actually, not too bad. 9 is going to be 9x, and x squared is going to be x cubed over 3, with a bracket from -3 to 3, and then all times radical 3, which is out in front. And we're ready to plug in bounds. So we're going to plug in the top minus the bottom. We'll plug in 3 and we'll plug in -3. A little shortcut, if you want a little calculator tip, I guess you could say. If I wanted to type all this into a calculator, although I could do this in my head pretty easily too, but just a little hint. You can go to your y equals and you can type in this function. You can type in 9x minus, and then I'll make it x cubed divided by 3. So x cubed divided by 3. And the reason I'm doing that is if I type it in here and I just save it, and you don't have to save, but you just quit out of here, it's not going to go anywhere. I can use this vars option, this vars button, and scroll over to yvars and pick function. And I used y1 as my function. And I want to plug in 3, so I can do y1 of 3. And then I'm going to subtract, and I want to find the bottom bound, -3. So I go vars, yvars, function, y1 of -3. And it'll actually plug 3 and -3 into what you typed in, so you're going to get 36. So that means we have 36 for this whole piece times radical 3. Radical 3 times 36 is what this ends up being. So volume equals 36 times radical 3, which if you multiply that on your calculator, let's get that decimal in. 62.353. So this is about 62.353 units cubed. And I got my answer. And we're